So I want to talk about these problems, such as the person who wrote the textbook, or the people who did, decided that it should be really important for you to be able to look at that thing and tell them about the intercepts without doing work, which requires memorization, which I think is a bad plan. They expect you should memorize some stuff. I'm not even going to tell you what it is. You can look it up in the book if that's the way you want to go, to decide whether this is going to have x-intercepts or y-intercepts. We have a way of knowing that anyway. This has a y, an x, and a number that's not 0. So both of those are going to be 1. Okay? They get a little tricky because they like to say, well, what about if x is missing? What if y is missing? I hope you memorize that and never forget it till the day you die or you're dead to me. That's crazy. What we have here is this will have, because it's a sloping line, and it does not go through the origin thanks to that 3, it's going to have one of each intercept. So that's what I like to do. And then those questions are going to come at you in different times. Then they say, why don't you find those 2 intercepts? Okay, let's do that. I'm going to let x equal 0. And when I do that, it's not too bad. When I let x equal 0, I'm not going to do a t-chart to get this done. I'm going to let x equal 0. In goes 0. I'm going to have y equals negative 3 over 4 times a 0, then plus negative 3. That means that y equals 0 plus negative 3. Use your calculator as much as you can or need to, but y equals negative 3, that's not too bad. It's all about here getting some arithmetic done after I know 0 goes in for x. This gets me 0, negative 3 for one of the points, so I'm happy with that. So let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0, negative 3. One of the points, beautiful. Because what I'm thinking is, when I looked, it had an x and a y and a number, so it's going to have 2 intercepts. And now I try 3 divided by 1, no problem. 3 divided by 3/4, I don't know what that's going to look like. We'll have to see how that turns out. It turns out it's a little bit more work. We should be good at all the work we've done earlier in the class, but why would we work the hard way when there might be an easier way to do it? Well, let's see what happens. 0 goes in for y. We have 0 equals negative 3/4 x plus negative 3. Now I want to get the 3/4 x away from the negative 3. And I don't want the negative 3/4 x. I want that to become positive. So I'm actually going to go ahead and add 3/4 x to both sides. So this is going to be completely gone. I'm going to get the 3/4 x over here, and that equals negative 3 over 1. And now you need to know what to do with that, because we're not knowing what x is yet. So what happens? Well, we're going to recognize that there's a GCF situation here. An LCD we want to do here. We want to cancel the denominator. That is a 4, that is a 1. I'm not worried about that 1, but this 4 is problematic for me. I want to get the lowest common denominator of all terms on both sides, and that's 4, and I want to put it over 1. Because we have a fraction in an equation, we're going to multiply through by the LCD, get rid of all the fractions, keep the same result for what the solution is. We got 3 over 4, space before the x, equals negative, and then I have 3 over 1 and space behind it to put my 4 over 1. Here we go. Times 4 over 1 times 4 over 1. You could do your canceling. You can multiply them out with your calculator or get 12 over 4. But if you do this all out, this becomes 3x. Canceling the 4s would be one way to see that. Equals. Now this is negative 3 times 4 for negative 12, but this is over 1 and that's over 1, so it's really all with integers now. And it turns out if we divide those by 3, we'll get x's negative 4. So there we got negative 4 for x and 0 for y, and we got the kind of thing we're looking for. Negative 4, 1, 2, 3, 4, right there. So if I put in negative 4 for x, the 4s will cancel, and it'll be the opposite of negative 3. It'll get me 3 minus 3 and hit the 0, and that actually works. The other one was when I put in a 0 for x, I straight away got it using arithmetic that my value for y is negative 3, and there are the 2 points. I'm ready to graph this thing. That wasn't so bad. Except this is going to cause trouble for some of the students who have other options. By the way, we found the 2 intercepts, so guess what? There was one of each. Here they are found, so we answered that. They want me to graph it, pass the line through it, it's done. What else might we do? Well, I think we could have done this. We can put in 0 jump, double jump. So 0 is going in, jump by 4, jump by another 4 and get 8, and we'll see what happens. And in each case, I'm going to put in a number. When I put a 0 in there, I know that it's going to make negative 3. And that point I already have. When I put a 4 in there, I'm going to see that I have y equals And what we've got with the isolated y as it came to us was negative 3/4 times my 4, and then plus 3. Let's see, and yes, so we're going to get negative 3 plus negative 3. We're going to get negative 6. Then we'll go do the 8. Y equals negative 3/4 times the 8. And we'll get negative 24 over 4, negative 6, plus negative 3. It's going to get me negative 9. So that's okay too, but we have a problem. This graph, for example, on Connect Math, might end at the 5s. When I go to graph 4, negative 6, I'll go out here to the 4 and I'll drop here, and when I reach the 5, I'm off the graph paper. So that does exist on the extended graph line that goes forever, but does not fit on my graph. And the 8's even worse because I can't place the 8 and I can't place the negative 9. It's still on the pathway. It belongs on the pathway of this line, doesn't fit on my graph. So then in that case, if I'm doing a 3-point method, I might have to go in here and use negative 4. I can drop down instead of up. The jumper can go forwards, going up by 4, or backwards, going downward by 4, and try negative 4. And if I put the negative 4 in, you're going to see that it returns 4, 0. And that will also get me a point 3. Now I have 2 points that are on my line. Negative 4, 0 is found the way that I would have it here. Y equals negative 3 times negative 4, negative 3/4 times negative 4 plus negative 3. So let's get these guys doing the right job. And we're going to come out of here with negative. The canceling of the 4 and the negative 4 gives me negative 1 times negative 3. I wind up with 3 plus negative 3. Gets me the 0 that I had found in another way to get me this point. If I need another point, I'd have to go to negative 8. And unfortunately, that's also off my graph. So those are the only 2 points I can fit on this graph. And I wind up with a graph of the line looking like this. What I suggest you do is look at the questions that they ask you, but don't feel as though you have to answer that question before you can do any more work. When it says how many x-intercepts are there, how many y-intercepts are there, why don't you go try and find the y-intercept or the x-intercept? And if you find them both, then when the time comes, tell them there's one of each. And then you're ready for it, and then we can go about doing this. But we do know, not through memorization, but that if there's an x and a y and a number that's not 0, there's going to be one of each on this graph of a line. So I have another one. And I just wanted to make sure we had a look at this one. When we're solving for the intercept, sometimes we got to work a little bit harder with the algebra than in some of the other cases. So we've got this one, and here's what's happening. We do have an x, we do have a y, we do have a number. So I do know there's going to be one of each. I could go ahead and try and find them and see what that's going to do for me. But there's one of each, and what are they? Letting x equal 0, letting y equal 0, I can go find them, see what we come up with, graph them, and we're ready to put the line together. Here's the thing. If we continue, we can recognize that 8 divided by 3 is going to give me a decimal or a fraction, whereas 8 divided by 2 will give me 4 for some kind of integer. That means that these are not really graphable. They are approximatable, as I like to call them. You can find a spot between them and then get a sketch to work, but you're not going to be able to drop this number in and know, this is one of those cases where is that like 3 out of 7 or is that 5 out of 9? The integers are easy to see, but fractions are tough. This is not going to end up with 2 integers when we get our intercepts. Let's find out what we get though. First one is actually, we're not going to look y, but it turns out the first one's okay. Letting x equal 0. We got 3 times 0. Plus 2y equals negative 8. This is 0 plus 2y, still equals negative 8. And 0 plus 2y is the same thing as 2y. And negative 8 minus 0 is still negative 8. And we divide by 2, and that wasn't bad. Y is negative 4. So we got this ordered pair where the y is negative 4 because it's an intercept, the x is 0. So that's one of them. So that I can put down there. So I'm going to go ahead and do that. 0 cross down 1, 2, 3, 4, and that's good. So I'm on my way to getting this line graphed. Next one though, it's going to ask me to let y equal 0 and deal with what that does. It's not too much worse at the beginning. Let y equal 0. So when I see y, I put in 0. I got 3x plus 2 times 0, so it's not 20. It's going to make a 0 right there. 3x plus 0 equals negative 8. 3x plus 0 is 3x. So I have that to be negative 8 divided by 3. and x winds up sticking at -8/3, which is about almost -3. What you have to do here is you have to divide by 3 and get 2. You find that 6 with a remainder of 2. It's 2 2/3. See the problem with that? It's not just that people don't like fractions. It's hard to graph it perfectly. It's impossible, I think, for humans to graph it perfectly. Computers, we could debate whether they could do it perfectly, but this has got to be about -2 2/3. So you do need to find out where that is. And now you're going to go to the right 2, and you're going to try and go 2/3 of the way to get into 3, between 2 and 3. That's not easy to do. I'm not saying it's not easy because math is hard. It's just hard to be that accurate. You will get a good sketch if you do make that. What else do we have as an option? Well, if we have our 3x plus 2y equals -8, and we isolate y, so getting the ability to nail down on how to isolate y is very helpful. It gives you options like this. If I take away 3x from both sides by subtracting 3x, this is completely gone. I have 2y, not y yet, but I have -3x plus I have -8. I'm going to divide each term where it sits by 2. And let me show you the y equals -3/2 stays intact with a jumper of 2 plus -4. I have that. And because the 8 didn't divide by 3, I find that this might be a preferable position to have myself in for graphing. Why is that? Well, because I have a jumper of 2, so x, y, 0, jump by 2 to 2, jump by 2 more to 4. It's going to give me the points that I need to graph 3 points that have integers for their coordinates. So I have y, I got the first one. When I put in 0, I already found 0 in for x gets me -4. That's already on my graph, so I'm good with that being there right here. But if I didn't even go into that, needing to approximate where that root would be, which is that intercept right there, the x-intercept, I can go let y equal and do the formula for this value of what y is on that line using x is 2. So I have -3/2 times 2 plus -4, and therefore that's going to get me -3 plus -4 and get me -7. Here's the problem. That may not fit. Turns out this does go out to 7 the way I did draw it, so I'm going to be able to get this 2 -7 on there. And so if I have 2 -7, I can see that I go to the right 2 and down 7, and I'm going to hit that one. Now if I go ahead and do 4, it's going to be way off. 4 is not the problem, but 7 is going to dig even deeper down. I can't do that one. So I'm not going to use 4. Instead, I'm going to take 2 and go backwards from 0. I'm going to go 0 minus 2 and create -2, not everybody's favorite. I'm going to try y equals -3/2 times -2 plus -4. This whole thing, canceling the 2's, is going to get me +3 plus -4, and eventually get me a 1 that's negative. Therefore, I'll have this option as well, and it still fits on my graph. Even if that 7 wouldn't fit, I do have a chance to go to -2 and -1, and I get this one. And if you look, they all line up, and they get me integers. Now that approximate value that I had is good, but it's only as good as you are at locating where that's going to go. So it's kind of tough when you don't get an integer for your roots. So that's why I say it's really helpful when we have to graph lines that we recognize when is a good time to use intercepts and when is it a better idea to go with something else. But in the end, we need the sketch of what the graph's pathway looks like, and we've graphed the line. There are going to be steps along the way. They're going to ask you to work through some of the material, make sure you've mastered some of that, but graphing the line is key. All right, we'll see you again soon.